Hi there! Today we're going to talk about estimations. Why do we need estimates? How do we do estimates? What's good about it? What's bad about it? So if you're interested in this, stay tuned. I'll be right back. So estimations. If you look in the Agile world about estimations, then I think the most popular tool out there is what is called planning poker. Planning poker is having this kind of Fibonacci-like numbers in your hands as planning poker cards. And then somebody is giving you information about an item to estimate. Somebody is giving information on an item to estimate, most probably because they have created that item without the involvement of the team. And that's where planning poker comes into place, because now the team is thinking about, yeah, this is the requirement, this is the feature, this is the thing we need to do, and now we need to estimate or figure out, is this now a 1, a 2, a 3, 5, an 8, a 13, 21, and so forth. So they have their cards in their hands and they need to think like, okay, what do I think it is? It's, you know what, it's close to a 5. So I take a 5 for myself. I don't show it to the others because that would influence the others. So I keep it for myself. All the others in my team are doing the same thing. If everybody has chosen their number, that's the moment when we turn around the card and show it to the others. What is happening now? The outer layer, so the smallest numbers and the highest numbers, can discuss why they think it's a 13. And then another person can discuss why they think it's a 2. So they discuss about a 2 or a 13 relevant to that item. Why do they do this? Most probably because they didn't understand the requirement well enough. They didn't build the requirement well enough. They didn't understand what it meant for other people in the team on how to interact or get this item done. Meaning they have this kind of mini waterfall in their Scrum teams. I do analysis, you do the development, somebody else does the testing, and we don't bother about each other's work, so we don't really collaborate. And in that sense, planning poker is a useful technique, because now we're going to discuss about those items and build some kind of relevant information. So if you look at planning poker, it's not that much about the estimate, it's more about the discussion. It's about the discussion and the sharing of the information. If you have watched my previous videos on the purpose of Scrum elements, about collaboration in the team, then you will understand that this kind of conversation already happened in a refinement session or in a planning session or anywhere else. So there's collaboration ongoing. We don't need to have the discussion when we do the estimation. So planning poker, a great technique. If the teams didn't create the items in their backlog, the items they need to work on themselves. If the team truly collaborated in creating these items, then the discussion or the use of planning poker becomes less useful. Another trap with planning poker is that we discuss this one item and we discuss numbers. A 2 or a 5, we don't really compare to anything else. Is this one item? The trap there is that we keep going into more and more details about this one item, spend a lot of time. And if we spend a lot of time on an estimate or something, this estimate is there also to judge, are we still going to do it, yes or no? Because if we estimate something very high and we understand the value is very low, then most probably we're not going to execute upon that anymore. So we're spending lots of time for something that might become completely useless. So we want to limit this amount of time so that we can use the free time then to really build added value towards our product that is today important, that we know is important today. So we want to limit this time. Planning poker, not that useful. Another side effect is that people become overconfident in their estimations and the plan that comes out. You know, this plan that comes out and the estimation is still going to be an illusion. Then again, there are many organizations that need this kind of estimate for what I would call a rolling wave planning. A rolling wave planning takes into account that change will happen, that there will be new things coming in, that there will be new things added at the back, that the things will shift around. So that's why it's a rolling wave plan, not a fixed plan. So in that context of a rolling wave plan, of the mindset of a rolling wave plan, that's when estimates are indeed useful. If it's estimates for a fixed plan, that's just encouraging people to stick with an illusion that is in reality will bite your ass. So we don't want that. In a context and a mindset of a rolling wave plan, we want to play ball with having some kind of estimate. And if we do Scrum as is intended to, and we do refinements very well, then the teams don't need to discuss details about the requirement. They don't need to discuss about the collaboration that needs to happen in the team, the testing and the development, the analysis, the security. All of that stuff is already being discussed. So planning poker is not the most effective way. We need to come up with other practices. And if you look at other practices and the rolling wave planning, then we need to start with a paper that has been written in 1979 by Kahneman and Tversky. They created a paper which is called Intuitive Prediction, Biases and Corrective Procedures. If we do estimates, it's an intuitive prediction. And what did they discover in that paper, or what do we need to bring from that paper, is that people are generally very optimistic. They underestimate cost, time and risk, while overestimating the benefit. We see this in business environments definitely. You know what? We have an item in a backlog and everybody says, this is going to be tremendously valuable. It's going to be hugely valuable. And then if we do estimates, we always go too low. And then at the end of the sprint and end of projects, then people always come back and say, you know what? The estimate is wrong. It shouldn't have been a 5. It had to be a 13 and all that stuff. It's very normal. It's been proven in this paper already as well with this research that people are generally just too optimistic on the effort that they need to put, the cost, the time and the risk, while being optimistic on the value. We need to go back and see, okay, how can we now approach estimation more appropriately? Is it by going more into details and in depth about what we need to do? Because that's the general tendency that we get if people need to go with an estimate. They say, okay, we need more details, we need to understand it more properly. So they spend lots of time going into that details with the illusion that they will have a better intuitive prediction happening. You know what? The paper that I just talked about already showed that it's still going to be very wrong. But we spent lots of times on figuring out details for something that we might not even need to build later on. All the time that we spent on something that we might need to build in the future is time wasted, is time lost in building added value today. It's not maximizing value for your organization. So it's not the most effective practice to go into more details and then figure it out. It's also from a lean thinking perspective a pure waste in going into the details while we have more valuable work ongoing at this moment in time. So it's not the right thing. So we need to figure out and look at some more research eventually to see, okay, what would be a more effective practice in our context to get towards useful estimates without spending a tremendous amount of time on details, a tremendous amount of time on discussing, but generally go fast. And we have found a practice where we can estimate hundreds of items within a single hour. Those have been described already in the past. This time I'm going to give you the explanation in this video, so stay tuned. The first thing that we need to go to is the Delphi Method. The Delphi Method has been coined during the Cold War, discussing the probability, the strategy forecasting. It's a very complicated thing, but if we need to take something with us, then we see that the Delphi Method tells us we need to go and consult the experts to give some ideas about probability factors and all the rest of the stuff, and then take this into account, have more of the discussion to come to consolidated, unified, better strategy and moving forward. So if we take this with us, then we understand that we need to have at least 2 experts involved in the estimation. That's a good thing to know. There's a research paper, it's called the Delphi Method, and it shows us as well, we cannot estimate without the experts. Who are the experts? The people building that need to do the work. So this is a clear indication that we need to indeed go to the teams building the product, building the feature. We need at least to have 2 experts, preferably 3 or 4 experts. Do we need a whole team? No. We don't need the whole team. So if I look at many implementations of planning poker, then the whole team needs to estimate. Some people don't know what it, or not the expert in that domain. They should not be involved. You know, leave it to the experts, even if it's only 2 or 3 experts. That's good enough. And this is what we want to go to. We want to have good enough for our rolling wave plan. We don't want to have accurate, because the illusion of being accurate in estimations is a dream. It's an unreachable state. So we don't even want that. We just want it good enough. So a couple of experts, that's what we get from the Delphi method. Check. So let's go further on. What is another practice that we need to combine with the expertise now, if we don't want planning poker? So then we find this research where Kahneman has won the Nobel Prize of Economics with, which is leading us towards the reference class forecasting. What is a reference class forecasting now? It's about distributional information that we use from previous actions to plot out our new actions on top of it. So we need reference classes, we need buckets of data. Buckets of data, buckets of actions, buckets of things we did in the past, so that we now can evaluate the new items, comparing to the buckets, the classes that we have built up to the items in those classes to see, okay, is it related? Is it like this, or is it more like something else? Is it bigger or smaller? So you do this kind of triangulation with reference classes, not with a single item, not with planning poker. You really build buckets. How do we now build buckets? We don't have those buckets. We need to start building up our reference classes. The first thing that you will need to do, you will need to have actions, items, features from the past. So take about 100, maybe even 200 items from the past. And you need the experts that have executed on those items in their past. They definitely know what it is about, don't they? And the first thing we want to do with this 100, maybe even 200 items is to put them into reference classes, which we will call small, medium, and large. People will ask you, yeah, but what is small about? What is small? And then you need to clearly state to them as well, we don't know yet. We are going to see what is small with the data points, with the items you put in there. So the definition of what is small will come from the data points, the information we acquire. If we first want to have a definition and then figure out which items do fit, then we are going to discuss most probably for days on a definition. So we don't define, we let it emerge. Imagine that. Emergent architecture, emergent reference classes, emergent numbers maybe. So it's about let it grow from the insights, the learnings, the data points, the depth that we see. Don't define and then try to match it in there. We first want to learn and then define. So we have small, medium, large, and people will put items in there. We basically do this like centrally with lots of people looking at one person. And we say, okay, this item, small, medium, large, oh, it's a medium, boom. This item, is it bigger or smaller or similar? It's similar, okay, medium. This item, bigger, smaller, oh, it's bigger, whoop, bigger, in the large. So at that moment in time, we have 3 reference points. What do? We distribute items to the number of people and ask them to work as pairs or trios. The 3 amigos, you know, or duos is okay, you know. We need 2 experts, at least 3 experts is better. So we distribute papers of past activities. If with my buddies here, if we get an item in our hands and we see, you know what, this item we understand and we can evaluate, if we now look at the medium size or 2 items, yeah, you know, it's smaller than this one, it goes into the small. If we look at the item and my buddy has something, I have no idea what this is about, and I have no idea what this is about, but we know another duo over there and definitely will understand this item, then we just go to that duo and give this paper. Then the experts can do the same exercise of figuring out which bucket is more related to the item in their hands, yes or no. If we don't know who to bring and we don't know what the item is about, we just put it aside. And then we continue with the 10 or 15 items we have got and we put them in the buckets. If our 10 or 15 items are done, we go to the leftovers and we continue. So we take the leftovers and we see, okay, well, we do the same practice. And we keep repeating this with the 2 duals and trios until we have the 100 or maybe even 200 items spread into small, medium and large. If we have small, medium and large, then we give the population a bit of time to look like what is in the small, what is in medium, what is in large. And are we okay with the current bucketing of our items? If they are okay with bucketing of their items, sometimes there's one item going from small to medium or the other way around. So this might happen. If it's a lot of items, then that's fishy, by the way, but some items might happen during that time. And now we have small, medium, large. So it's not good enough, you know? This is too big of variation, not that useful for a rolling wave plan, so we need to continue. Well, how do we continue? We collect all the mediums, we put them aside. We collect all the large, we put them aside, and we continue with the small. And within small, we are going to divide into small, 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 medium, small, large, and small, extra large. And then we use this information that is there and we divide this. We do this again with duals or the three amigos. Because we already viewed them when we put them into the small, this is going to go faster than the initial exercise. So now we have 4 columns. If this is done and people are okay with the current deviation or bucketing of items, now we take the mediums, and in the mediums we say, okay, you know what? Next to the small extra large, we have the medium small. And now we have medium medium, we have medium large, and we have medium extra large. We give this around and we ask people again now to put this in this thing. It might be that the small extra large goes into the medium small, or a medium small goes into the small extra large. You know, there's a bit of overlap between the small and the medium there, and that's okay. So now we have a multitude of columns, and then we repeat this with our large column. And now we have a multitude of those columns. There is an exception with the large, because if you go to large, you will have large, extra large, but for the fun of it, and also to be more predictable in our rolling wave forecast, I also add the large double X large, and now we have the large triple X large, just to make sure that there's also within the large, extra large still a distinction possible, if needed. So now we have a multitude of those columns. How do we now continue so that we get numbers? Because we need numbers and a certain velocity, capacity that the teams can handle. If you need to understand about why I say teams, then please go and look at the video I created on the fallacy of the low numbers. Then you will understand that teams is better than team, that team is better than an individual, and so on. I'm not going to elaborate on this in this video. There's another one for that. If we have this done, now we need to go to numbers. We go to the small, small column. So the first column that we have built up. And this first column, we are going to call this a 2. Why do we have 2 and not 1? You know what, in the future there will always be something that might be smaller than your small, small at this moment in time, so we leave this space open. So we call this a 2. And then we continue. Now we ask the people if this is a 2. So you look at the items that are there, and this we call 2. Then if you now look at the columns on the right side of it, or on the side of it, then which column there do you think is at least double as big as this 2 column, if you compare items? And then we can use body voting if it's a physical workshop, then people go and stand in front of the column they think is at least double as big. If it's a remote online workshop, then you have columns being put on a online whiteboard, and then you can use voting, for example, for people to vote on a column that they think is at least double as big as the 2 column. And then the one with the most bodies on it, or the most votes on it, that's the one which you will call 5. And then people will go, huh? 5? We went from 2, I expected 4. Why do you put 5? You know what, the bigger you get, you have a bit of slack there, and you know, the bigger the estimations become, the more uncertainty will creep in, the more risk will creep in. So having a bit of slack over there doesn't hurt anybody. It will help you out being more predictable in your rolling wave planning anyhow. So we call this a 5. Between the 2 and the 5, we can still have a 3. So we add this 3 column. If there's no 2 or 3 columns below it, then people need to decide. Either it stays in the 3, it goes to the 2, or it goes to the 5. So this goes pretty fast. Why? It's already the second or the third time people will need to go to the same items. It's in their head. So things start to move pretty fast in that sense. Now we take the 5 column and we do the same thing. Which column next to it do you think is now at least double as big as the 5? We call this a 13. And in between the 5 and the 13 we can have an 8. We do this shifting again, then we take the 13, we go to 21. There's nothing in between 13 and 21, so if there's columns in there, they need to either move to the 13 or the 21. Just to make sure we can balance it out over time with the bigger items. Again there, if you want to understand more about bigger numbers and why there's a gap over there, please go and watch the movie about the fallacy of the low or small numbers and you will understand perfectly. So if we have 21, we go to 42. I tend to use 42. Yes, I'm a nerd. I'm still a nerd. So 42, the answer to everything instead of 50 or anything else, 42. Then we go to 100. From 100, we restart the things. Then it's 200, 300, 500, 800, and off you go. So the bigger it becomes, the bigger the differentiation is, and that's a good thing. You know, if you want to estimate between 1,000 and 1,001, you know, this 1 point or this one thing, one banana, one kiwi, it's not worth a discussion. It would be wasteful time. So now we have buckets with numbers on top of that. We're going to collect the buckets, and I tend to do this in a kind of a matrix structure. And why a matrix? It helps in estimating new items in the future and also maintaining our matrix over time. So we create a matrix which, for example, has space for 10, maybe 15 items per square in our matrix. And I create a matrix with 3 columns, and then we have rows. So if we look at the first row, then we have number 1 in the first column, we have number 2 in the second column, we have number 3 in the third column. If you look at the second row, it will continue with number 5 in the first column, number 8 in the second column, and then we have 13 in the third column. And now we have the third row, and we continue there with adding the numbers. Why do I do this now? Why don't I just put the columns next to it and that's it? You know what? We do a refinement session with people. They extract an item for their product backlog, and now this item needs to get an estimate. If they don't take this item, which they just discussed, we don't need discussions, we don't need planning poker, we just need an estimate, then they will have an assumption on which row somewhere it will become. It's about the row, it's not about the number or column anymore. So we discuss a row where we think it belongs. So it's either very small, it's somewhere a bit bigger, it's a lot bigger, or it's huge. Those are what the rows pretty much mean. So people will generally have a quick understanding which row. If we understand it's the second row, for example, then we go into the central space, so the second column, and we look at the items there and we compare with the items in our hands. And then we have a discussion in relation to the items, the data points that we see in front of us. So we don't discuss the item and a number, no, we discuss this item versus other items from the past, from the current. So we are really going to use this kind of reference class forecasting. We're going to use the distributional information that is available to us to see, okay, does this new item now fit this column, yes or no? We compare with the items. In the discussions, what do we want to hear? We want to see here, like, yeah, if I look at what we want to estimate at this moment in time versus some item in this box, then I think it's a lot bigger because of in the comparison. We don't discuss this item is bigger because of blah, 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 and more details about this item. No, it always needs to be in comparison with some reference data. It might be that they look and they have the discussion, it's like, whoa, the one that we have here is a lot bigger. If it's a lot bigger, then we move a row down. And then we have the same discussion again. Now we're at the third row, we have the same discussion. It's like, yeah, you know, I think it's still a bit bigger than what we see here. Then we move to the right side, to the third column on the same row. And most probably this will be the finishing point. So this kind of estimation goes pretty quick. Similar thing might be, we look at the second row, we look at this thing, oh, it's a lot smaller, then we move one up in the center. We look in there, yeah, you know, it's a little bit smaller, we move one left. So we always go with a row in the center and then either go up, down, left or right. Or we immediately hit the sweet spot and the estimation is over. Once we understand it's similar, we put the item there, and that's the moment when we look at the number that is assigned to that box. We don't look at the number before we assigned and compared. The number is the only usefulness of that number is to use it in the mathematics, the calculation for your rolling wave planning. It has zero other use. So that's why we cannot focus on the number. We need to focus on the comparison, the reference classes. We need to do this with the experts. So reference class forecasting, Delphi method, we combine it together. We make it a very useful practice and then we move forward. If you want to understand how this is done in a, for example, in a remote world, then you know what? Here you will see an example of this kind of matrix on how it is being used with clients I'm supporting at this moment in time. This is how we do estimates. We use the matrix to limit the effort that we do to acquire good enough estimates for our rolling wave plan so that we can have more time available at this moment in time to work on added value in our product instead of trying to estimate something that might happen in the future. I hope this video will help you and your colleagues and your teams in getting better at estimates, in using estimates more appropriately for a rolling wave plan, and at the same time don't spend too much time on it so that you can use your time in the more joyful stuff, adding new features, creating new products. So I hope this was great. So I hope to also see you later. There will be more on estimations and planning and all that stuff coming on later anyhow. For now, on estimation, I guess that's good enough. If you want to stay tuned, if you want to discover more about estimates, planning, and all other stuff which is related to simplifying organizational structures or using large-scale Scrum more appropriately in your context, then subscribe to my channel, go to the ringer, and I hope I will see you again in future videos. Bye bye.